Find the area between two curves. Step 1, put one of these guys into y1 and put the other guy into y2. And you don't have to write down who you've put where on your test, but I do because I forget. Step 1, get those cats in the calculator. Now, and this is critically important, hit your window key on the calculator. So hit window. And set x min to whatever, you're going to set your x's to these boundaries.
1 and 6.
Yeah. And then zoom fit.
Do you draw it?
Yes. So that's my f of x. And that's my g of x. If you're on a black and white screen, it always graphs whatever's in y1 first. So watch it. Once you hit zoom fit, watch, because you gotta know who's where. While you guys are doing that, something else you have to do on these is you have to show by hand what these antiderivatives are. So you have to somewhere over here, just literally off to the side, but you have to do it. You have to antiderive these guys. Over here. Just antiderivative practice. Why not? Okay, so what you do need to know
Isn't
is
it
that...
plus C? It's not plus C?
No, because it's a definite integral. Definite integrals don't have plus C. Because it's what we're doing is this is an x value of 1, and this is an x value of 6, because that's how we set the window. And in this little portion, the f function is above the g function. So for this section, the antiderivative would be from 1 to some number, it's f of x minus g of x dx. And then from there, which we don't know, from here to 6, they change places, and g is now above f. So you always do, when you're doing area between two curves, it's the top curve minus the bottom curve. So you have to graph it to see where they cross and find that exact value. And the way you do that is you hit second calc and you select intersect. Second calc, second trace, however you want to think about it. Second calc, intersect, and it's going to arbitrarily drop the cursor on whatever you have stored in y1, and it's going to say first curve, and I say yes. And then it puts the cursor on whatever's in y2, and it says, can I call this the second curve? And you say yes. And then it says, would you like to guess? And which, if you want to move your cursor kind of closer to that spot, you can. But it says that that exact x coordinate is 2.283. Is that what you guys got?
Yes.
So from the starting left point to 2.283, so from here to there, the area is described by the equation of the function on top minus the equation of the function on bottom. And that's f on top of g. And then, kind of like a balloon animal, they twist and do places. So now all of this can be done on the calculator with Math 9, which is nice because doing it by hand would be a real time commitment. So I hit Math 9, And I'm telling my calculator to do y1 minus y2 from there to there. And then over here for math 9, it's y2 minus y1 from there to there.